In question 1, we're given the graph of y is the modulus of 3 minus 2x, and we need to solve modulus of 3 minus 2x is equal to 7 plus x. Well, I will start by adding the line with equation y is 7 plus x. It's cutting the y-axis at 7. I could also identify the individual equations of these line segments here. So on the right hand side, we've got y is minus brackets 3 minus 2x. So we're looking at y is minus 3 plus 2x. And on the left hand side, we've got y is 3 minus 2x. So we can see that the gradient of this line segment here is 2. The gradient of this line is 1, and therefore we have an intersection point on the right and an intersection point on the left. So I will equate 7 plus x with 3 minus 2x, and 7 plus x with negative 3 plus 2x. So on the left hand side, we've got 3x is negative 4. So x is negative 4 over 3. And on the right hand side, we've got 10 is equal to x. So the two solutions are x is 10 and x is minus 4 over 3. In 2a, we need to sketch the curve with equation y is 4 to the x, stating any points of intersection with the coordinate axis. Where we're dealing with an exponential curve, we know that when x is 0, we've got y being 4 to the 0, which is equal to 1. We know that the horizontal axis is an asymptote, and therefore the graph should look something like this. So from left to right, it takes off, going off to infinity. In b, we need to solve 4 to the x is 100, giving our answer to 2 decimal places. So I will be using logarithms here. 4 to the x is 100. I will take log of both sides. So log of 4 to the x is log of 100. So x log 4 is log of 100, which leads to x being log of 100 over log of 4, which gives an answer of 3.32, correct to 2 decimal places. In 3, we've got a sequence of terms defined recursively here, and we need to show that this sequence is periodic and state the order of this periodic sequence. So we know that the first term of the sequence, a1 is 3. Now a2 is 8 minus a1, so it's going to be 8 minus 3, which is 5. Then a3 will be 8 minus a2, which is 8 minus 5, which is 3. I could do this for a4. It's 8 minus a3, which is 8 minus 3, which is 5. And therefore, we can see that the sequence goes 3, 5, 3, 5, 3, 5. So we have that all the odd terms, a1, a3, ... are all equal to 3, and all the even terms a2, a4, ... are equal to 5, and therefore the sequence is periodic. Now for the order, well, the sequence repeats every 2 terms, so a1, a3, a5 are all the same, and then a2, a4, a6 are all the same, and therefore the order is equal to 2. In b, we need to find the value of the sum of the first 85 terms. So the sigma notation here refers to summation. So sum of an from n equals 1 up to 85, which means a1 plus a2 plus a3 plus a4 plus ... plus a83, a84, and a85. Now, over the first 84 terms, we've got 42 repetitions of the period. So we've got 42 times the 3 and the 5. And then the 85th term here is the start of a new period, which is a 3. So this summation here is 42 times 3 plus 5 plus 3, which gives an answer of 339. In 4, we need to use differentiation from first principles to show that the derivative of 2x squared is 4x. I will start by defining my f of x to be 2x squared, and then I will find f of x plus h, which is 2 brackets x plus h all squared. So this is 2 brackets x squared plus 2xh plus h squared, which simplifies to 2x squared plus 4xh plus 2h squared. Now we know that in the formula sheet we are given the definition of the derivative from first principles. F dash of x is the limit as h tends to 0 of f of x plus h minus f of x over h. So in our case we will be replacing f of x plus h with 2x squared plus 4xh plus 2h squared minus f of x, which is 2x squared, and all of it over h. Now the 2x squared with the 2x squared cancels out. I see a common factor of h in the numerator, so this is going to be the limit as h tends to 0 of h brackets 4x plus 2h over h. So the h cancels out now, and as h tends to 0, the 2h goes to 0, and I'm left with just 4x. And therefore we conclude that the derivative of 2x squared dy dx is 4x as required. In question 5, we are asked to use the trapezium rule to estimate the integral of log 2x from 3 to 9. So we start by saying that the height of the trapezia is the difference between two consecutive values of x, so it's 1.5, and therefore we can say that the integral of log 2x base 3 from 3 to 9 with respect to x is approximately a half times the height of the trapezia, which is 1.5, and then it's the first and last y values once. So 1.63 plus 2.63 plus 2 times all intermediate y values. So 2 times 2 plus 2.26 plus 2.46, which leads to an answer of 13.275. Now in B, we need to use the answer to part A to estimate these two integrals here. So for the first part of B, so BI, it's the integral from 3 to 9 of log of 2x to the 10 base 3. So we know that the 10 can come down, so it's the integral of 10 log of 2x base 3 dx. So this will be 10 times the integral of 3 up to 9 of log 2x dx. So these will be approximately 10 times 13.275, which gives an answer of 132.75. In II, we've got the integral from 3 to 9 of log of 18x dx base 3. So I will write log of 18x as log of 9 base 3 plus log of 2x base 3. We know that if I've got log of 9 plus log of 2x, then that's the log of 18x. So essentially I have split 18x as 9 times 2x. The limits are 3 and 9. Well, the log of 9 base 3 is simply 2, and I split the integral from 3 to 9 plus the integral of log 2x base 3 from 3 to 9. Now the second integral is exactly what I have estimated using the trapezium rule, and this one here is simply 2x from 3 to 9 plus the 13.275. So this will be 2 times 9 minus 2 times 3 plus 13.275, which gives an answer of 25.275. In 6, we are given a sketch of 8 sine a half x minus 3x plus 9 for x being positive, x is in radians, and we need to use calculus and the sketch in figure 2 to find the x-coordinate of P, which is a local maximum point. Well, if you think about it, we will be setting f dash of x is 0 because we're looking at the stationary point, and we want the first, second, third positive solution. That will be the x-coordinate of point P, because if you look at the graph and we are explicitly told to use the sketch, we start with a maximum, then a minimum, and then a maximum. This is the point P. We're looking for the third positive solution for f dash of x being 0. So we start by writing f of x here is equal to 8 sine a half x minus 3x plus 9. We differentiate, we get f dash of x will be 8 times a half cos over half x minus 3. So this is 4 cos over half x minus 3. I will set this equal to 0, and we get that 4 cos over half x is equal to 3, which means that cos over half x is equal to 3 over 4. Now the principal value here will be shift cos of 3 over 4. Remember, we are in radian mode. This gives an answer of 0.72273, and therefore we get that x over 2 is plus minus my principal value of 0.72273 plus 2 pi k. If I multiply throughout by 2, I get that x is plus minus 1.44547 plus 4 pi k, and the three first positive solutions are x is 1.45, 11.12, and 14.01, and therefore we conclude that at P we have that x is 14.0. In B, we are told that we've got a cross on the x-axis at x is alpha, and in addition we've got that f of 4 is 4.274 and f of 5 is minus 1.212, and we need to explain why alpha must lie in the interval 4 to 5. Well, we know that if we've got a change of sign and f of x is continuous, then we are having a root, i.e. alpha must lie in the interval 4 to 5. And therefore we state that there's a change of sign and f of x is continuous, hence alpha lies in the interval 4 to 5. Notice that both the change of sign and the continuity need to be stated to score the mark. In C, we need to start with x naught being 5 as the first approximation to alpha and apply the Newton-Raphson method once to find a second approximation to alpha. We know that the Newton-Raphson process tells me that xn plus 1, the next iteration is xn minus f of xn over f dash of xn. So we have that x naught is 5 and therefore x1 is 5 minus 8 sine of 5 over 2 minus 3 times 5 plus 9 over 4 cos of 5 over 2 minus 3, and this gives an answer of 4.80. In question 7, we are asked to find the first 4 terms in ascending powers of x for the binomial expansion of the root of 4 minus 9x. So we start with the square root of 4 minus 9x, which I will write as 4 minus 9x to the power over half. I will factor out the 4 and it will inherit the power, so 4 to the half outside, and then in the bracket I've got 1 minus 9x over 4 to the power over half. So this is gonna be 2, this is 4 to the half, and then we've got 1 plus a half times minus 9x over 4 plus a half times minus a half over 2 factorial times minus 9x over 4 squared plus a half times minus a half times minus 3 over 2 over 3 factorial times minus 9x over 4 to the power of 3 plus dot dot dot. So we've got the expansion. All that is missing is for me to simplify the terms. So this is 2 brackets 1 minus 9x over 8 minus 81x squared over 128 minus 729x cubed over 1024 plus dot dot dot, which further simplifies upon expansion to 2 minus 9x over 4 minus 81x squared over 64 minus 729x cubed over 512 plus dot dot dot. In B, we are told to use the answer in part A without doing any calculations to state whether this approximation will be an overestimate or an underestimate of root 3, giving a brief reason for our answer. Well, if you look at the expansion here, we notice that after the first term, the 2, all subsequent terms are negative, and therefore if I was to include all the terms here, I would be seeing all negatives here. So just using the first 4 terms here means that I'm having an overestimate because the terms that are omitted here will make the actual value less. So we conclude that all terms after the first one are negative, and hence the approximation is an overestimate. In question 8, we've got this graph here. It's the curve with equation x minus 2x minus 4 over 4 root x, and we are asked to find the shaded area R. We start by noting that the cuts on the x-axis are at 2 and 4. These are the values of x for which y is 0. We can see this from the factorized form of the numerator, and we will be using integration to obtain the area R. Before I actually proceed with integration, I will take the expression for y and write it in index form. So y is x minus 2 times x minus 4 over 4 root x. I will expand the numerator to get x squared minus 4x minus 2x plus 8 over 4x to the half. This is x squared minus 6x plus 8 over 4x to the half. And I will write this on a 10 by 10 basis. It's x squared over 4x to the half minus 6x over 4x to the half plus 8 over 4x to the half. And this gives me a quarter x to the 3 over 2. Remember, when I've got division with a common base, I subtract the indices. Minus 3 over 2x to the half plus 2x to the minus a half. So we can now proceed with integration. We said that the lower and upper limits are 2 and 4 respectively. So we increase the power by 1, divide by the new power. So it's a quarter x to the 5 over 2 over 5 over 2 minus 3 over 2 x to the 3 over 2 over 3 over 2 plus 2x to the half over a half, and the limits are 2 and 4. Before substituting the limits, let's look at some simplifications. The 4 with the 2 leaves me a 2. The 3 with the 3, the 2 with the 2, they go away. So we are looking at x to the 5 over 2 over 10 minus x to the 3 over 2 plus 4x to the half from 2 to 4. I will substitute the upper limit of 4, and I've got 4 to the 5 over 2 over 10 minus 4 to the 3 over 2 plus 4 times 4 to the half. This is the upper limit of 4, and now we'll substitute the lower limit. It's 2 to the 5 over 2 over 10 minus 2 to the 3 over 2 plus 4 times 2 to the half. Now the first bracket here will give me a result of 16 over 5, And for the second bracket, we notice that I could factor out 2 to the half here. So that's going to be minus 2 to the half. And I'm left with 2 squared over 10 minus 2 to the 1 plus 4. So this leads to 16 over 5 minus 12 root 2 over 5. Now notice that this number is negative. Let's explain why this is negative by going back to the graph here. The area R lies entirely below the x-axis, so when we integrate, we get numerically a negative result. However, we know that area is always measured in a positive sense, so I need to make sure that I'm reporting a positive value. So the area of R will be 12 root 2 over 5 minus 16 over 5. In other words, I took the negative of the answer I just obtained from the integral to make sure that I'm reporting a value for area which is positive. In question 9, we're modeling the height, capital H, meters, t seconds after the wheel starts running through this equation here, and we are told 3 pieces of information. The first one, that the maximum height is 50 meters. The second one, that the passenger is a meter above ground when the wheel starts turning. And finally, that the wheel takes 720 seconds to complete the revolution. And we need to find the exact value of A, the exact value of B, and the value of alpha to 3 significant figures. So this is the equation we were given. Modulus of A is sine bt plus alpha. And we know that the maximum height, so the maximum H, is exactly at A, because sine of any angle varies between plus minus 1, and therefore the maximum will be at A. We are told that this maximum is 50, so capital A is exactly 50. We are also told that when t is 0, we have that capital H is 1. So if I substitute t is 0 here, we get 50 sine alpha. So 1 over 50 is sine of alpha. I do shift sine of 1 over 50. We are in degree mode. We get that alpha is 1.15. Now, for the last piece of information, that the wheel takes 720 seconds to complete the revolution, I will be looking at the period of the sine wave. So I will start by drawing the sine graph, then we'll consider the modulus of it to see exactly how the period is affected. So this is the graph of sine t. We can see that it repeats every 360 degrees, so it has a period of 360. And looking at the equation of the model, we can see that the A here is multiplying the y values by A, so it's not affecting the period. The alpha is just a translation to the left, so it's not affecting the period. The only thing that's affecting the period is the B here and also the modulus sign. So it will make sense to actually draw the modulus of sine t next to the sine t to see how the period is affected. And we see that the part of the curve that was below the t-axis is now appearing above. So it is now repeating every 180 degrees, and therefore the period is 180 degrees. So we need to consider now how the B here is affecting the period. So at the moment, we know that the graph of sine t is repeating every 180 degrees, and the graph of sine of bt is a stretch along the horizontal scale factor of 1 over b, which means that we multiply the t values by 1 over b. So it will have a period of 180 over b. So this period is the time needed for a complete revolution, and we have been told that this is 720 seconds, and therefore 180 is 720 b, which makes 1 over 4 the value of b, and therefore we conclude that the model is capital H is the modulus of 50 sine of a quarter t plus 1.15. In B, we are asked to explain why a model of this form, where this is a positive constant, would be a more appropriate model. Well, if we go back to the model we were given here, we can see that this predicts a minimum height of 0, which is assuming that the lowest point that the wheel can attain above ground is 0. We know that in reality this is not the case. We usually mount a wheel from a platform which is a certain distance above ground, and therefore we want the lowest point of the wheel to be above ground and not touching the ground. And therefore we can conclude that since we want the lowest point of the wheel to be a distance of d above ground so that the passenger does not touch the ground, this makes a model of this form more appropriate. In turn, we've got the function f here, and we need to find f inverse of 3 over 2. So I will start by saying I want to find f inverse of 3 over 2, which I will call x, and I will actually do f of both sides. So f of f inverse of 3 over 2 is f of x. Now f of f inverse is simply 3 over 2 because f is undoing whatever f inverse did, and f of x is 8x plus 5 over 2x plus 3. I will cross multiply to get 3 brackets 2x plus 3 is 2 brackets 8x plus 5, which leads to 6x plus 9 is 16x plus 10, and therefore minus 1 is 10x, and this leads to minus 1 over 10 being the value of x. In B, we need to show that f of x can be written in this form where a and b are constants to be found. What I can do here is simply do long division. So I will divide 8x plus 5 by 2x plus 3. So dividing 8x plus 5 by 2x plus 3, I need a 4. 4 times 2x is 8x, 4 times 3 is 12. I deduct. I see a remainder of negative 7, and therefore we can see that f of x, which was 8x plus 5 over 2x plus 3, can now be written as 4 minus 7 over 2x plus 3. In C, we're given another function g of x. It's 16 minus x squared for x between 0 and 4 inclusive, and we need to state the range of g inverse. Now the prompt to state means that it's something obvious, no calculation is needed. We know that the domain of a function is the range of its inverse, and therefore we can easily conclude that the range of g inverse are all values between 0 and 4 inclusive. And now the difficult part is part D. We need to find the range of f of g inverse, and we need to start by considering that we will first be conducting g inverse, and g inverse will be giving me results. The output of it will be values between 0 and 4. So the idea is for me to sketch f of x and then consider the output that g inverse will give me. So we've got that f of x is 8x plus 5 over 2x plus 3. If I was to sketch this, I know that we've got asymptotes. So the first asymptote, the vertical asymptote, is at the point where the denominator becomes 0. So when 2x plus 3 is 0. So we've got x is minus 3 over 2. For the horizontal asymptote, we consider the behavior of y as x tends to infinity. And as x tends to infinity, y tends to 8x over 2x because the 5 and the 3 are insignificant compared to the size of 8x and 2x. So this will be 8x over 2x, which is 4. So we've got an asymptote at y is 4. In addition, we know that when x is 0, we're looking for the cut on the y-axis. Y is 5 over 3, and when y is 0, we've got 8x plus 5 is equal to 0, and therefore x is minus 5 over 8. So I've got enough information for me to draw f of x. So this is the graph of f of x, but we know that we're looking at f of g inverse. So g inverse, we said, will output between 0 and 4. So we can see that we have the limits at 0 and 4 there. So the graph is here only. Let me put the 4 there. There it is. And we know that when x is 4, f of 4 is equal to 8 times 4 plus 5 over 2 times 4 plus 3, which gives an answer of 37 over 11. And therefore, when x is 4, the y value here will be 37 over 11. So once more, with blue, it's f of x, and then for g inverse, it's between 0 and 4. So the output of g inverse will be between 0 and 4, and therefore we will be having f of g inverse attaining values between 5 over 3 and 37 over 11. So this means that the range of f of g inverse will be y belongs to the reals, comma, 5 over 3 less than or equal to y less than or equal to 37 over 11. In 11, we need to prove using algebra that n times n squared plus 5 is even for all n in the natural numbers. Now, a reminder that the natural numbers are the positive integers. So I will consider an exhaustive approach here where I split all the integers as being even or odd. I will start by considering n being 2k, where k belongs to the integers. So I'm taking first the case that n is even. Then n times n squared plus 5 will be 2k times 2k squared plus 5, which is 2k times 4k squared plus 5. We notice the factor of 2 here, so we conclude that this is even. Now, we will also consider the case that n is odd, so consider n is 2k plus 1, where k belongs to the integers, and then this means that n times n squared plus 5 will be 2k plus 1 times 2k plus 1 squared plus 5. So this means that we're looking at 2k plus 1 brackets 4k squared plus 4k plus 1 plus 5, which simplifies to 2k plus 1, 4k squared plus 4k plus 6. That is a common factor of 2 in this second bracket. So this can be written as 2 times 2k plus 1 times 2k squared plus 2k plus 3. And therefore we also conclude that this is even. And we need an overall conclusion. We say that hence n times n squared plus 5 is even for all n in the natural numbers. In 12, we're given f of x here, and we need to show that its derivative can be written into this form where g of x is a function to be found. I will be using the quotient rule of differentiation here. So I start by differentiating the top, which gives me 3e to the 3x, and I keep the bottom, 4x squared plus k, minus keep the top, and I differentiate the bottom to give me 8x, and all over the bottom square, which is 4x squared plus k squared. So I notice that there is a common factor of e to the 3x, and I'm left with 3 times 4x squared plus k minus 8x, and all of it over 4x squared plus k squared. And this leads to e to the 3x brackets 12x squared minus 8x plus 3k over 4x squared plus k squared. and we can see that g of x is simply e to the 3x over 4x squared plus k all squared. In B, we are told that this curve here has at least one stationary point, and we need to find the range of possible values of k. We do know that k is a positive constant. However, we need to take into account this extra piece of information to see what kind of restrictions we can impose on the values that k can take. Now, we know that for a stationary point, the first derivative should be 0, and we can see that e to the 3x can never be 0, so the number of stationary points stems out of the number of solutions of 12x squared minus 8x plus 3k being 0. So let's start by stating that we want f dash of x to be 0, which simply means that e to the 3x times 12x squared minus 8x plus 3k, and all of it over 4x squared plus k squared is 0. Now, for at least one stationary point, we want the discriminant of the quadratic to be non-negative. So we want this to be greater than or equal to 0. And we're looking at the discriminant of this quadratic here. So the discriminant is b squared minus 4ac. So in our case, it's minus 8 squared minus 4 times 12 times 3k, and this should be greater than or equal to 0. So 64 minus 144k greater than or equal to 0. 64 is greater than or equal to 144k. 64 over 144 simplifies to 4 over 9 greater than or equal to k, and I also need to include the condition that k is positive that was given in the question itself, where it was said that k is a positive constant. In 13, we've got the point A, B, C, and their position vectors, and we are told that A, B, and C lie on a straight line, and we need to find the value of P. I will start by finding the vector AB. So the vector AB is simply the position vector of B, which is 0, 4, 6, minus the position vector of A, which is 4, negative 3, 5. And this gives an answer of negative 4, 7, 1. And I will also find the vector BC, which is the vector C minus 16, P, 10, minus the vector B, which is 0, 4, 6, which gives negative 16, P minus 4, 4. Now we know that A, B, and C are 3 points on the same straight line, and this means that the vector AB and the vector BC should be parallel. So minus 4, 7, 1 should be parallel to minus 16, P minus 4, and 4. And therefore, we can take these two entries here and say that their ratio should be the same. So 7 over 1 is equal to P minus 4 over 4. I will cross multiply to get 28 is P minus 4, and therefore P is 32. Now in B, we have that the line segment OB is extended to a point D, so that CD, the vector CD, is parallel to OA, and we need to find the length of OD, giving our answer as a simplified third. I will start by using the fact that OB is extended to a point D, so OD is a multiple of OB, lambda times OB, so it's lambda times 0, 4, 6. In addition, I could say that to go from O to D, I can go from O to C and then from C to D. Now, OC, we have that, that's not problem, but CD, it's parallel to OA, and therefore it's a multiple of OA, so mu times OA. So OC is minus 16, 32, the value of P we just obtained, 10, plus mu times OA, which was 4, negative 3, 5. And I have just expressed the same vector OD in two different ways. I can equate the first entry here because it will make this 0 anyway, so lambda will not appear. So lambda times 0 is minus 16 plus 4 mu. So this leads to 0 is minus 16 plus 4 mu. 16 is 4 mu, and therefore we found the value of mu to be 4. This means that the vector OD will be minus 16, 32, 10 plus 4 times 4, negative 3, 5, which gives an answer of 0, 20, 30. I still need to find the magnitude of this, so the magnitude of the vector OD will be 0 squared plus 20 squared plus 30 squared square root, and this gives an answer of 10 root 13. In 14a, we are asked to express 3 over 2x minus 1x plus 1 in partial fractions. So we start by saying we've got 3 over 2x minus 1x plus 1, and this can be written as a over 2x minus 1 plus b over x plus 1. Remember, this here means equivalent to, which means it holds true for all values of x. I can get rid of the denominators by saying that 3 is a brackets x plus 1 plus b brackets 2x minus 1. And since this holds true for all values of x, I can choose any value of x I want. If I set x to be negative 1, we see that 3 is equal to b times 2 times minus 1, because the x plus 1 became 0, so a was eliminated from this equation. So this leads to 3 is negative 3b, and therefore we've got that b is negative 1. I will proceed by setting x to be a half, and I get 3 is a times a half plus 1. The 2x minus 1 is now 0, so b is eliminated. So we have that 3 is 3 over 2a, and therefore we conclude that a is 2. And so we've got 3 over 2x minus 1x plus 1 is written in partial fractions as 2 over 2x minus 1 minus 1 over x plus 1. In B, we need to solve the given differential equation here. Given that exactly 2 hours after the chemicals were mixed, we had a total volume of 3 cubic meters of oxygen produced. This will be the boundary condition that will help us determine the unknown constant. So this is the given differential equation. I will start by separating the variables, which means I will collect the v with dv on the left hand side and the t's with dt on the right hand side. So this leads to 1 over v dv is 3 over 2t minus 1t plus 1 dt, and I integrate both sides. I also recognize that the integral on the right hand side, I can use the partial fraction decomposition we just did in part A. So the integral of 1 over v is simply ln of the absolute value of v, and on the right hand side it's the integral of 2 over 2t minus 1 minus 1 over t plus 1 dt. So we have that ln of the modulus of v is the integral of this. Now the integral of 2 over 2t minus 1, notice that 2 is the derivative of the denominator, so the integral will simply be the ln of 2t minus 1 absolute value minus the integral of 1 over t plus 1 is ln of the absolute value of t plus 1 plus a constant of integration which I can call ln a. We also know that when t is 2, v is 3. So this is the condition I'll be using to find a. So this means that we've got ln of 3 is ln of 2 times 2 minus 1 minus ln of 2 plus 1 plus ln a. So ln 3 is ln 3 minus ln 3 plus ln a. So the ln 3 with the minus ln 3 cancel out. We can see that 3 is equal to a, and therefore we can say that ln of the modulus of v is ln of 2t minus 1 minus ln of t plus 1 plus ln of 3. I will collect all the ln's on the right hand side into a single ln. So we've got ln of v is ln of 3 times 2t minus 1 over t plus 1. Because the addition here means multiplication and the subtraction here means division, that's why the t plus 1 appears in the denominator. The ln's can go away, leaving me with v is 3 times 2t minus 1 over t plus 1 as required. Now in part C, we are told that there was a time delay between the chemicals being mixed and oxygen being produced, and there was a limit to the total volume of oxygen produced, and we need to deduce this time delay giving our answer in minutes and also the limit giving our answer in cubic meters. So let's start with the first piece of information. There was a time delay between the chemicals being mixed and oxygen being produced. Recall that this is the equation we found for V in terms of T. V is the volume of oxygen produced, and obviously we need to observe that we need the V to be greater than or equal to 0, and this will only happen for 2t minus 1 being greater than or equal to 0, which means that t is greater than or equal to a half. So this is the time delay. T is measured in hours, and therefore we conclude that the time delay that we were after is simply half an hour or simply 30 minutes. Remember, we were asked to give our answer here in minutes, so 30 minutes for CI. Now for the limit in the total volume of oxygen produced, we need to consider the behavior of V as t tends to infinity. So as t tends to infinity, we can see that V tends to 3 times 2t over t. In other words, we have the minus 1 and the 1 here being insignificant, and therefore this is 6t over t, which is 6, and therefore this limit is 6 cubic meters. In 15, we've got the first 3 terms of a geometric series, and we need to show that 4 sine squared theta minus 52 sine theta plus 25 is 0. Well, we know that for a geometric series, the ratio is always the same, so u2 over u1 is equal to u3 over u2, which means I can write that 5 plus 2 sine theta over 12 cos theta is equal to 6 tan theta over 5 plus 2 sine theta. I will now cross multiply to get that 5 plus 2 sine theta squared is equal to 12 cos theta times 6 tan theta. I will expand the left hand side to give me 25 plus 20 sine theta plus 4 sine squared theta, and on the right hand side 12 times 6 is 72 cos theta, and I'll be writing tan theta as sine theta over cos theta. We notice that the cos theta cancels out, and therefore collecting everything on the left hand side gives me 4 sine squared theta minus 52 sine theta plus 25 is 0 as required. Now we are also told that theta is an obtuse angle measured in radians, and we need to find the exact value of theta. So it makes sense to start by solving the given quadratic in sine. I will use factorization for this. We've got 2 sine theta minus 25 times 2 sine theta minus 1 being 0. So either 2 sine theta minus 25 is 0, or 2 sine theta minus 1 is 0. So we've got that sine of theta is 25 over 2. Obviously, this is not valid. We reject this because we know that sine theta is between minus 1 and 1. But on the other hand, we've got sine theta is a half. So we can say that theta is shift sine of a half, which is pi over 6. However, we need to take into account that theta is obtuse. Since theta is obtuse, then we've got that theta is pi minus pi over 6, which gives me an answer of 5 pi over 6. In C, we need to show that the sum to infinity of this series can be expressed in this form, k brackets 1 minus root 3. So I will actually start by finding the first term. I'll find the common ratio and use the formula for the sum to infinity for a geometric series. So I start by drawing a triangle. We know that sine theta is a half, so opposite of a hypotenuse. Pythagoras gives me the adjacent to be 2 squared minus 1 squared square root, which is root 3. And we also know that theta is in the second quadrant, it's obtuse, and therefore cos of theta is adjacent over hypotenuse, and in the second quadrant the cosine is negative, so cos theta is minus root 3 over 2. So u1, we were told that this was 12 cos theta, so this is 12 times minus root 3 over 2, which gives an answer of minus 6 root 3. u2 was 5 plus 2 sine theta, so this is 5 plus 2 times sine theta, which is a half, and this is equal to 6. And therefore we can conclude that the common ratio R is simply u2 over u1, which is 6 over minus 6 root 3, which turns out to be minus root 3 over 3. We're now going for the sum to infinity. We know that the sum to infinity is a over 1 minus r, where a is the first term. We found this to be minus 6 root 3, and the common ratio is minus root 3 over 3. I will start by multiplying everything by 3. This gives me minus 18 root 3 over 3 plus root 3. So I got rid of the fraction in the denominator, and I will now rationalize the denominator by multiplying by 3 minus root 3 over 3 minus root 3. So this gives an answer of minus 54 root 3 plus, well, 18 root 3 times root 3 will be 18 times 3. So 18 times 3 over a denominator of 9 minus 3. So this is minus 54 root 3 plus 54 over 6. I will factor out the 54, so I get 54 brackets 1 minus root 3 over 6. The 54 with the 6 leaves me a 9 in the numerator, so all in all this leads to the sum to infinity being 9 times 1 minus root 3, and therefore the constant k is 9. In 16, we are given the curve C defined parametrically here, and we need to determine the equation for the normal at the point where t is pi over 4 using parametric differentiation. We start by considering the parametric equations for x and y. So x is 2 tan t plus 1, and y is 2 sec squared t plus 3. So dx dt is 2 sec squared t, and dy dt is 2 times, get the power down, deduct 1 to go to sec t times the derivative of sec, which is sec t tan t. So this is 4 sec squared t tan t. We know that dy dx in parametric form is dy dt over dx dt, which is 4 sec squared t tan t over 2 sec squared t. We do have some simplifications here. The 4 with the 2 leaves me a 2 in the numerator. The sec squared cancels out. So this is 2 tan t. So at t is pi over 4, this is the value of the parameter that we were given. X is 2 tan of pi over 4 plus 1, which gives an answer of 3. Y is 2 sec squared pi over 4 plus 3. This gives an answer of 7. And dy dx is 2 tan of pi over 4, which turns out to be 2. Remember, we are looking for the normal, so the gradient of the normal, I will just flip dy dx and change the sign, so it's going to be minus a half. So I have now reduced the equation into me having the point and the gradient. So I will be using y minus y1 is mx minus x1. So we've got that y minus 7 is minus a half brackets x minus 3. I will expand the right hand side to get y minus 7 is minus a half x plus 3 over 2. So y is minus a half x plus 17 over 2 as required. In B, we need to show that all points on C satisfy the given Cartesian equation. In other words, we are asked to combine the parametric equations in order to derive the Cartesian equation for C. Once more, I will start by writing out the parametric equations for x and y respectively. So x is 2 tan t plus 1 and y is 2 sec squared t plus 3. We do know that sec squared t is 1 plus tan squared t. So sec squared t can be derived from the parametric equation for y. It's y minus 3 over 2. And tan t is x minus 1 over 2. That's squared. So we've got y minus 3 over 2 is equal to 1 plus x minus 1 squared over 4. And therefore I can cross multiply by 2 to get y minus 3 is 2 plus 2 brackets x minus 1 squared over 4. Now the 2 with the 4, they cancel out, leaving me with the 2 in the denominator. I will add the 3 to get that y is 5 plus x minus 1 squared over 2 as required. And finally, in part C, we are told that the straight line with equation y is minus a half x plus k is a constant, intersects at 2 distinct points, and we need to find the range of possible values for k. I will actually start by recalling that we have already established that the normal at P has a gradient of minus a half. So the line with equation y is minus a half x plus k will be parallel to this line. So let me draw a parallel line to this one. And if I start moving it around, I will see that we could have 2 points of intersection, no point of intersection, or 1 point of intersection. So obviously, because we are looking for 2 points of intersection, there are 2 limiting cases. The first one is here, where I cut at the end point here of the curve. And the other limiting case is when this becomes a tangent over there and we've got one distinct point. So the first case is this one over there, just touching on the point. The second case is this one with blue, where we just touch on the endpoint here. Let me start with the blue case here. I know that the endpoint here is when t is minus pi over 4. If I briefly go back to the definition of the curve here, we see that t attains value between minus pi over 4 and pi over 3. And we can see that the furthest to the left I can go, that's the furthest to the left for x, will be when t is minus pi over 4, and that's the point of interest here. So I'm substituting t is minus pi over 4 to get the point when t is minus pi over 4. X is 2 tan of minus pi over 4 plus 1, which gives an answer of negative 1. And y is 2 sec squared of minus pi over 4 plus 3, which is 7. So we pass through the point with coordinates minus 1, 7. The equation of the straight line is y is minus a half x plus k, and therefore y is replaced with 7, x is replaced with negative 1, and we get that 7 is a half plus k, leading to 13 over 2 being the value of k. So here we've got that k turns out to be 13 over 2. Let's consider the red line here when it becomes a tangent. Well, we know that the gradient here will be minus a half, and that will be the value of dy dx. So in other words, I start by saying that dy dx is minus a half. We have already established that dy dx is 2 tan t, and therefore minus a quarter is tan of t. Now we know that sec squared t is 1 plus tan squared t. So I know the value of tan t is minus a quarter. So sec squared t will be 1 plus minus a quarter squared, which leads to 17 over 16. And therefore x is 2 tan t, which is a minus a quarter, plus 1, which leads to a half, and y is 2 sec squared t, which is 17 over 16, plus 3, which gives an answer of 41 over 8. So we know that the point at which the line is tangential is at a half, 41 over 8. So once more, we start with the line y is minus a half x plus k. Y is 41 over 8. The x is a half plus k. So 41 over 8 is minus a quarter plus k, which leads to k being 43 over 8. And therefore, going back to the diagram here, we know that here k is 43 over 8. So we can easily conclude that we have to be less than or equal to 13 over 2, but certainly strictly greater than 43 over 8 for two solutions, for two intersection points. And therefore my final answer would be that we want all k such that k belongs to the reals, 43 over 8 strictly less than k less than or equal to 13 over 2 as a range of values for k.